Hello again. Today we're going to be talking about imaginary numbers. An imaginary number is a number that doesn't exist. That's why it's called imaginary. So we get them from any time we want the square root of a -1, because we know there is no answer for square roots of negatives. You can't take a number times itself and get a negative. So that's referred to as a negative or an imaginary number. So anytime you have square root of -1, we can replace it with the letter I. Notice that the square root goes away, because again, I is the square root of -1. So first example of the work you're going to see today is just doing some square roots of negatives. So what we'd want to do is we'd want to kind of break this out a little bit like a factor tree, a little bit like we were doing the other day with square roots. And we want to break it out so that we don't have the negative with the main number. We're going to break the main number away, leaving the -1. Now, I know the answer to square root 36, the positive version. That makes 6. I also now know the answer to the square root of -1. Even though it doesn't exist in real life, it exists as an imaginary number, 6i. Okay, so that's the first part of your work today, just to kind of get used to pulling out that -1 and then replacing it with an I. All right, so a complex number, that's the next step. It's an expression in the form a plus bi, where a and b are real numbers, but I is the imaginary number. And I want you to notice the order, that the imaginary term is listed last after the constant term. That is considered standard form. All right, so an example could look like this: 4 plus 3i. It's an example of a complex number. It's complex because it has a combination of real numbers and imaginary numbers. All right, let's try some examples of what our work will look like today. All right, so again, we're going to treat I kind of like it's a variable. All right, so this first one here, we're combining some like terms. We want to combine our constant terms first. The constant term goes in front here. So 4 plus 6 makes 10. Now the imaginary terms. 3 plus -7 would make -4i. Again, notice the order. The imaginary term comes last, after the constant term. All right, another one, a subtraction one. All right, constants first. -3 minus 5 makes -8. Then the imaginary numbers. 8i minus 2i makes 6i. So again, it works like a variable as far as how we do things with it. But again, it's not always perfectly going to work like a variable. It's got some quirky things because it's imaginary. But today we're not going to hit many of those quirky things. We're just going to kind of treat it like a variable, except again, it goes after the constant term, not before. All right, hopefully this isn't too bad for you today. Good luck.